Good afternoon, it's Postbag. So let's start with this yellow one, and today's background is brown paper, the non-shiny side. So let's get this one open, and it's just occurred to me why cutting mats are a good idea, particularly for Postbag videos. So the cutting mat makes a reappearance. Let's see what's in here. Transformer in there. Oh, that's going to take ages. I'll do that off camera. So what do we have here? Well, it's a little circuit board with two transformers, a larger one there, smaller one there, where we can see the winding. Now that might actually just be a choke. I think it is just an inductor, because I can only see two connection points there. There's a couple of transistors here. Can we see what they are? I'll get a torch in a moment. There's a class X2 capacitor there, rated for mains voltage, 275 volts AC. There's a MOV there, a metal oxide varistor to suppress mains transients, and there's a bridge rectifier. So this is clearly something to do with mains. And there isn't much else on here, just that resistor, which is, a high value, I think. No, 1.5K. No, not a high value. I thought the green was a mega ohm band, but no, it's the other way around. No capacitors on here, well, apart from that X2 capacitor. So what this is an inverter. The main side is actually the output. The input side is 12 volts. So this is a 12 volt to 220 step-up inverter. Oh, there are two resistors there. Perhaps one per transistor. What's that transistor? It's an A2099, and it looks like they're both the same, A2099. Okay, let's take a look at this item on eBay. Now, for some reason, eBay has no record of my purchase, which is a bit strange, but it's this one. It's a DC to AC inverter, 12 volts to 220 volts. 35 watt boost step up power module. This one is $2.88, free shipping, and this one is from eGoTo. Not much data on this other than a reiteration of the power 35 watts, input voltage and output voltage. But what I wanted to use this for is to take power excess voltage from a lithium cell and transfer it to all the cells in the pack. So in effect, I'm transferring power from a lithium cell to itself and all the other cells in series. And the transformer isolation means that I won't have any problems with the level of the cell within the pack. The issue is that this is designed for a 12 volt DC input. In fact, it sort of says that, but it's almost illegible. And it kicks out a 220 volt AC output. Now what I want is to run this off something like 3 volts and have, well, it would be a quarter, wouldn't it? So something like, what's half of 110? 65 or something like that. 65 or 55 it is, 55 volts out. And then the 55 volts would simply be put across the pack. That would be pulled down and the pack would charge. So will this run at about 3 volts? Well, I guess there's only one way to find out. Well, I've been gaily wiring this up with the output from my power supply, which I was going to put 12 volts on, to the 12 volt input. It does have 12 volt minus 12 volt plus. And I've attached the AC, what I assume is the AC output, to these 2 points, but I don't think it is now, because these 4 points along here are the bridge rectifier. Let's just get in a bit closer. This is minus, this is plus. And it's just occurred to me, why would you have, this is AC and this is AC, why would you have a bridge rectifier on an inverter from DC to AC? Why would you then turn it back into DC again? So I'm not quite sure, maybe there was a particular application for this. But anyway, the AC outputs appear to be here and, well, here, and then it goes through the MOV, and so this could be an AC output. Now, is the MOV just a protection device? in series with the output. That seems a rather strange thing to do. So actually I think I'm going to leave this to another video, because this could take a while. Even if I put the DVM on this and see that there is an AC voltage, I won't know the frequency, and so I think I'm going to need to put the scope on it. So I think I'm going to move on at this point. Now this one is already open, and in fact it's been cut open. I think it's been cut open by customs or something. So this one's very easy to take apart, and it is an analog meter. I was going to say an analog DVM, but it's not really a DVM at all, is it? It's an AVM. So yeah, this was a dirt cheap analog multimeter, the MF110A, and there is actually a diagram of it here with various resistors for the different ranges, AC and DC volts, DC milliamps, and also resistance. There's a 1.5 volt battery. I'm not sure whether that's in there. Can probably have a look if we take that screw out. The test leads are truly horrid. The switch movement is just completely nasty. But let's put it on 10. There's just no sort of certainty to that switch movement at all. Let's put it on 10 volts DC and measure a 9 volt battery. Right, so shove the probes in here. These look like 2mm pins or thereabout. So that's on DC volts. Let's measure the battery. Oh yeah, pretty good. So I need the range that goes up to 10, which I think is that red one. Now of course parallax is an issue, so I need to get this on axis with the camera, but at the same time gravity is pulling that needle down, so that's putting a bit of offset on it as well. I now remember why analog meters are a pain to use. There's no mirror on here either to get a parallax lineup of the meter needle. So in fact what I'm going to have to do is tilt my camera, I think, and have it directly above. Let's do that. So first I've got to zero this out by putting a screwdriver in this mechanical zeroing thing. Oh, that's a bit horrible, but you can see that moving something along there. So we've just got to zero that out. Right, that's about right. Now let's put the test probes onto the battery. And we're reading 8 point something. Let me get my hand out of the way because that's not helping, is it? Well, what is that? About 8.5 volts. I suppose I can compare that with my DVM. Okay, DVM says 8.60, so yeah, I guess it's not a million miles out. I suppose this could be useful. Let's have a look at it on eBay. Well, this is another one that's curiously disappeared off my purchase history, so maybe a seller has been removed from eBay or something like that. But anyway, it's this type. I'm sure I paid less than that. A new MF110A electric AC/DC ohm voltmeter ammeter analog multimeter. $6.75 this one is, free shipping, and this is from Nonvoy. So let's have a quick look inside here at the 1.5 volt battery holder. Oh yes, there it is. Ooh, what size is that? These terminal strips are just horrid. They're totally bent. Well, that looks like it might be a AAA. There's the pot, which has a manual turn capability. That's probably for zeroing out ohms. And the meter's got some sort of sticker over it, which hasn't been terribly well aligned, has it? Oh, I'll just shove that on. Yes, very nice. So let's put it's a AA by the look of it. A AA cell in there. Oh, is it a AA? Well, if it is, it didn't fit very well. That's really horrible because the AAA was loose and the AA is fiercely tight. Oh well, let's give it a try. Ohms. X1K, X100. Oh, well, let's go for 1K because I just happen to have a 1K resistor here and I can't bring myself to use the probe, so I'm just going to bend the leads. Oh, these are very corroded. Not bent correctly. Let me rebend those. Well, I don't know what's going on here because in the ohms range this zeroing pot doesn't seem to do anything. So I don't know what's going on there. And then I looked on the back and there's what appears to be a dead short between the red and green wires going to the meter. I mean, there can't be. There is actually a tiny gap there. There's the tiny gap between the red and green wires, but that's a bit grim, isn't it? I think I'm just going to move that over myself so that the red and green wires are definitely not touching. It does seem to measure this resistor, sort of, although quite badly because that's a 1K resistor, and here on the ohms range, what am I getting? 3 ohms? I don't know. 250? No, that must be... No, ohms must be just that top scale. It gets very condensed up at this top end. Is this pot doing anything now? Oh, it is doing something now, yeah. So why is that not measuring 1K? That's on the times 1K. Oh, times 1K. So maybe if I zero that out on 1, well, there we are. It's measuring 1K. 1 times 1K. It's moving around a bit. Let's try times 100 now, and that should read 10. Well, it doesn't really, does it? So let's make it read 10. 10 times, oh, that's right up at the top of the range. So that's 10 times 100 ohms is 1K. And that's now reading over range. What a heap of crap. So I'm not sure I can really recommend this, certainly not for ohms. I think I'd put it on a par with one of these cheap battery testers. I mean, it might be okay for measuring DC volts, possibly just doing quick battery checks, but no, I think, and given the price of this, $6 or something, I think you're better off actually buying one of the cheap digital multimeters. Don't bother with an analog. So let's measure the 1K resistor on the... Oh, and it's exactly 1. That's actually pretty good. I like this more now. Let's do it on the... Oh, that dial is really soft. Okay, that might need a little bit of zeroing out for the times 100. So let's measure it on that one. And that should read 10. Oh, well, now that doesn't read 10. That was zeroed out, wasn't it? Yeah. No, it doesn't read 10 times 100, giving you 1K. It's completely wrong. Yes, it's rubbish. I've damaged my brown paper now. That's a shame. Okay, next up is this one. Oh, got this problem of not being able to cut on the not mat, haven't I now? What have we got here? What? Ah, yes, this is the electric bag sealer super sealer. Let's have a look in here. This is a bright pink electric bag sealer. You can see there's a little piece of wire there and a foam pad, is that? Yeah, it's a bit of a sort of foam rubber pad with a high temperature coating on it. Little piece of wire there, and this runs off 2 batteries, 2 AAs, I believe. Right, so let's put these 2 AA batteries in there. Now, where's the switch? Oh, probably pressing that in. I don't know, is that heating up? It's very hard to tell. Well, let's get let's get a bag. Oh yeah, I can smell something getting hot now. This cover for the battery is vaguely magnetic. I don't know why that would be useful, other than just to sort of stick it on the side of your fridge or something. There's also a funny flap here, which I presume is just a protection thing. Let's get a bag. Right, I've got some very tiny bags in here, which I bought, I think, for packing components. I can't quite remember. And the first thing that's immediately obvious is it's not really going to seal a very big bag unless you go across it in steps. Unless the idea is that you seal a twist at the top of a bag. But how practical is that? Let's try doing that. Is that sealed? Well, it's melted and chopped in half. So it looks like some, oh yeah, that smells nice. So it looks like some practice would be needed to get the timing of the press right. Let's press that for a bit less time. This twisting the top thing is a bit of a nuisance. Okay, let's give it 5 seconds. That's just a bit of a mess. Okay, well, in order to see what I'm doing, let's just do some little seals. Let's do half a second, 1 second. But actually all this is doing is just melting holes. It's getting closer. You can see that this has just melted straight through. If I pull it apart, it's obviously just cut straight through. So, I mean, the fact that this has absolutely no temperature regulation on it means it's completely useless. Okay, let's have one attempt at sealing across this bag, which I'm going to have to do in little mini steps. Oh no, this isn't going well. What a load of old rubbish. Well, this is another one that's mysteriously disappeared off my purchase history. I don't know why they're all disappearing. These are available cheap. I mean, this one is priced at 99 cents. Oh, 99 cents shipping, so effectively $1.98. This one is from Buy-in Soon Hua. Now, interestingly, they show it with that flap thing up, and there are some instructions down here. Designed with ease of use in mind. Place edge of poly or mylar bag in your sealer and slowly pull the bag through. Perhaps that's what I'm doing wrong. Right, one more attempt with this plastic thing up, although I don't quite see how that's going to work. But let's try it. No, that's not going to work, is it? That's just going to make lots of heat underneath where the wire is. But how's that going to get through to the bag and slowly pull it through? What's that mean? It's not doing anything. Let's pull it through. Well, let's pull it through this way. I know that's not going to make a very good or useful seal. Oh, that's just ridiculous. It's rubbish. No sense putting good batteries in useless tat. So those batteries are coming out. Okay, let's try this one. Electronic parts. What's that? Well, they're diodes. Now, at first glance, they just look like cheap 10 amp sort of high voltage rectifier diodes, but they're not. These are marked 10SQ045. So in fact, these are only 45 volt reverse bias diodes. 10 amp, but you can only put 45 volts on them, more than 45 volts, and they'll actually conduct in the reverse direction. These are Schottky diodes. Now, when I made my solar charge controllers, I had an external diode in the yellow wire in the solar incoming positive, and I used this, the 90SQ035. I went for the 35 in the end because I was able to get it at a better price than the 45. So this is not 90 amps, this is 9 amps, 35 volt maximum reverse bias, and these are 10 amp 45 volt reverse bias. So in some ways these are a better bet, but you couldn't buy this sort of high power Schottky diode on eBay at the time when I was making these. So these came from, I think, Radio Spares. So these are in my purchase history. These are 5 pieces. It is 5 pieces, yep. 10 SQ045, 10 amp, 45 volt, Schottky rectifiers, new, just 99 cents for the 5, free shipping. Now these came from Alice 110 1983. So I'm pretty sure I bought these to replace this one in my Muppet solar charge controller, my MPPT solar charge controller. This is in the buck regulator section. You've got the inductor here, the Schottky diode here, and the switching MOSFET here. Now I'll get in a little bit closer. So the diode in here is actually a TSR 845. So this is an 8 amp 45 volt diode. I'm pretty sure I bought these from someone on eBay before I was able to get the SQ one. So you can see that the 8 amp is a smaller diameter than the 90 SQ035, and then if I bring in the 10 amp, you can see that it is correspondingly much fatter. And really this is all about heat dissipation, and so you want a large surface area to get rid of the heat generated in a 10 amp diode, and correspondingly less in the 9 and the 8 amp diode. So here's one of the PWM5 solar charge controllers. There's the diode underneath a little piece of yellow heat shrink in the yellow wire. I found another one here where the covering's been cut off for whatever reason, and there is the 90 SQ035 diode sitting external to the unit. The primary reason for it being external is that this thing can get quite hot when a substantial current is flowing through it. I think the controller was rated up to 6 amps and it's a 9 amp diode, but these would get quite hot. And so these are today's Postbag items. Some good, some bad. Cheerio. And so these are today's some complete rubbish and some... No, that's no good. Bollocks.